everybody. So just to start with a quick announcement, I have some travel planned for Thursday through Sunday. So I can't be at office hours or hold a lecture on Friday for this course. So there are no there are no office hours or lectures. No office hours Thursday or Friday, no lecture on Friday for this class. All right, so in the previous class, we were talking about Java enumerations. Right? Now, remember what you would want to use an enumeration for, right? So you use an enumeration when you've got a class that represents a bunch of objects. When you have a class where the objects of the class, there's only a limited, usually small number of them, right? And those objects are actually constants, so their state never changes. Right? So here's our enumeration for days, right? There's only 7 days of the week. When you make an enumeration, everything by default is public, including the enumeration itself, I believe. So to create the enumeration, it's normally quite simple, right? Instead of a class, you make an enum, so that's the keyword for Java enumerations. Right? The name of your enumeration is the same as, use the same conventions as the name for a class, right? So uppercase letter, use camel case. And then you just list your constants inside the body of the enumeration. Right? So here I've listed the days, Sunday through Saturday. Now this is important. You actually list them in the order that you want to compare them in. So I'm going to get to that in a moment. Right? So I guess in North America it's common that the week starts on Sunday, although that's not the convention everywhere else. Some places the week starts on Monday. So here I've listed them Sunday through Saturday. Right? To use the enumeration, it's straightforward. Everything's just a constant. Right? So to get to the constant Sunday, you just write day.Sunday, and that's your day. Right? So day.Thursday, well, that's a day. Right? I can print out the enumeration, and when you print it out, you get the name of the constant, which is nice. Right? So there's a toString built in. There's a toString method built in for you for the enumerations. It's even nicer if you want to, you can actually change or override toString so that it gives you a different string for each constant, right? And I'll show you, well, I'm not going to show you exactly how to do that, but I'll show you how to create a method for each constant in a little bit. The other thing, I guess one of the important things that you should remember when you're using an enumeration is that the language guarantees there's exactly one object corresponding to each of your constants. Right? So in your entire program, it's guaranteed that there's only one object called day.Monday. Right? There's exactly one object called day.Thursday, and so on and so forth. Right? So because you've only got one of each object, you can safely use equals equals and not equals instead of using the equals method. Although if you want to, you can still use equals if you like. Right? Enumerations are not allowed to have public constructors. Right? So no public constructors, so that means that a regular user cannot create extra constants. Right? That's one of the advantages and one of the limitations of using an enumeration. Right? It's an advantage. You don't have to worry about someone creating new objects on you. Right? It's a disadvantage in the case where you've incorrectly used the enumeration. Right? So an enumeration is supposed to represent a fixed set of constants. Right? If you're in the situation where you actually want to add constants to the enumeration, you have a problem. Because that's probably going to break other people's existing code when you do that. The other nice thing about enumerations compared to using just a plain old int or a plain old string is that you get type safety when you use enumerations. Right? So each enumeration is a separate type. Right? So the type day is different from the type month. Right? If you write a method that accepts a day, it's not going to accept a month object. Right? Similarly, if you write a method that returns a month object, right, you don't have to worry about getting back a day object. Right? All the type safety that you get that's part of Java, it's preserved when you use enumerations. Right? Enumerations also implement comparable for you automatically. Right? So the order in which you list your constants, that is the sorted order of your constants. Right? So for the months, it makes sense to list them from January to December in order. Right? Now, when you compare them, they compare in the order that you listed. Right? So January is less than February. Right? February is less than March, and so on and so forth. You don't have to implement this. You get it for free. Right? So enumerations implement comparable for you. Right? Now, the version of compare to that you get, you're stuck with it. You can't change it. Right? So unlike toString, you cannot change the way compare to behaves for an enumeration. Right? So it's important that when you list your constants, you list them in the order that you want to compare them in. Here's an example of using compare to with the month and, oh, this is with day, sorry, that's mistitled, using day. Right? So I have 3 days, day 1, day 2, day 3. Right? If I compare Monday to Thursday, right? So D1 compared to D2, right? Monday comes before Thursday, so I expect a negative number, and I get -3. Right? If I compare Saturday to Monday, the way my enumeration is set up, Saturday comes after Monday, right? So Saturday should be greater than Monday, so I should expect a positive number, and I get back 5. Right? When I compare Thursday to itself, so D2 compared to D2, it's the same day, I should get back 0. Right? The number that you actually get back, this actually means something with enumerations. Right? So with enumerations, you get back the difference between the 2 days. Right? So Thursday is 3 days after Monday. So Monday is 3 days before Thursday, so you get back -3. Right? Saturday is 5 days after Monday, so you get back the 5. Right? So here you get the difference in the location of the constants that in the order that you listed them in. All right, so you've seen very simple enumerations where you just list the constants and that's it. That's all you have to do. Right? Often that's all you have to do. So when you're creating enumerations, basically all you have to do is create the enumeration and then just list the contents, and for the most part you're done. Occasionally it makes sense to have an enumeration that has its own fields. And if it has its own fields, you have to initialize those fields via a constructor. Right? But remember, constructors are always private for enumerations. Right? And also remember that enumerations are supposed to be constants. Right? So if you're in the situation where you create an enumeration that does have some data, that data should be constant. Right? So what might a situation be where you have information in a constant? Right? Well, for the months, right, it might make sense to store the number of days in each month. Maybe. Right? February is weird because of leap years. Right? So February is a bit sketchy in this case. But this is an example of where you might want to associate data with each constant. Right? Now, when you create your enumeration, it still looks the same. It's just that when you declare your constants, you now have to call a constructor. Right? So the constructor for this month enumeration is going to take in the number of days for each month. Right? So January has 31 days, February has 28 days, and so on and so on and so forth. Right? Now, if I want to store these values, I need a field. So there's my field. Right? So it's private. It's called days, so the number of days in each month. Right? The number of days, that's an integer value, so int makes sense here. Right? Short would also work, I guess, in this case. Right? And notice here that you can, and you probably should, mark it final, right, to make sure that you don't accidentally create a field whose value can actually change, right? Because then you don't really have a constant anymore. Although I'm sure you can cook up some sort of use case where you do actually want a field that can change, right? Here I'm just going to mark it final to indicate that the number of days in each month is final. And again, we'll have to deal with February as a special case. Okay, so we're not quite done yet. I have to define a constructor for the class now. So there's our constructor. You can't make the constructor public, right? So the language says that constructors for an enumeration must be private. So the convention is to not put any access modifier here whatsoever. The compiler will automatically make it private. You can mark it private if you want to. You cannot mark it protected or public. Okay? So the constructor in this case is simple, right? It takes in the number of days, so you just set the field to the passed in number of days, and that's it. Right? And now you can do things like add methods to your enumeration. Right? So I can add a method that returns the number of days in a month for a given year. Right? So this is how I'm going to deal with February having 29 days in a leap year. Right? Okay, so February is the special case. Right? If you ignore the two if statements, right, the number of days in each month is just this dot days. Right? So for the most part, I can just return this dot days. Right? All right, so the first if statement. Right? Now remember, this is a non-static method, so it belongs to an object, right, or it's associated with an object, right? So that means to call this method, I need one of the month constants, right? So I need January, or I need March, or I need December, right? So using that constant, I'm now going to call the method called days, right? And I'm going to pass in the year for the to get the number of days for a given month, right? So inside the method, the object that you use to call the method is this, right? So if this month is not February, right, I can just return the number of days that's stored in the field, right? Now, if the number of days, if the month is February, I now have to check, is the year a leap year, right? So that if statement there tests, is the year a leap year, right? If it's a leap year, I return days plus 1, right? 29 days in February. Otherwise, I just return 28 in this case, right? And so there is an example of a enumeration that has a field. Because it has a field, it has a constructor, right? And it has a method that lets the user of the enumeration get back some information about each constant, right? So it basically looks like a regular class. It's called enum instead, right? The constructors are all private. Okay, sorry about that. All right, you get some other methods for enumerations when you use an enumeration for free. So every enumeration has a method called values, and it's static, right? So the values method returns back an array of all of your constants in the order that they were declared. So if I want to get all the months, right, as an array, I just call the values method, right? So month.values, that gives me an array, right? The array contains 12 elements, right? First element is January, last element is December, right? If I want to, in this case, I'm just going to print them out, right? So I'm going to print the array as a string. So when you do that, you get back the array January through December, right? And now you can iterate through this array, or you can do whatever you want with this array, right? But it gives you back all the constants, which is occasionally useful. Right, so here's another example. So I'm going to use the values method to get back the array of months. And I'm just going to iterate over all of the months, right? So for each month, M, I'm going to print out the number of days in, I guess, 2018, right? So here you should get 31. I don't remember now. You're going to get back all the days for each month, right? Oh, you get that. There you go. So you get 31, then 28, and then 31, and so on, and so on, and so forth. So enumerations give you a convenient way to iterate over all the constants. You also get a convenient way to generate one of the constants given a string, right? So you get a free static method, right, called value of, right? Value of, you pass in a string, and the value of method tries to give back the enumeration constant that corresponds to that string, right? So for example, right, if I want the object that corresponds to the month May, right, then I can pass in the string, M-A-Y, all caps, right, and I will get back the month that represents the month May. So if you have strings, which is often the case when you're reading in a text file or an initialization file of some kind, or if someone's typing stuff into the keyboard, right, you can automatically get back the constant that corresponds to that string, right? The strings have to match, right? So if you type in something like, I don't know, Monday for the month, then you get an exception, right? So value of throws an exception saying it can't create the month object corresponding to Monday. All right, so this one's a bit odd. You're allowed to add methods to your enumeration, right? So far for all of our classes, when you add a method, the method behaves the same for every object. Enumerations are different. So for an enumeration, you can have a common method that behaves differently for each constant. Right? So this is a bit of an unusual idea. Right? It'll make more sense to you when we talk about inheritance a little bit later in the course. Right? So the way this works is you declare what's called an abstract method, right, in the enumeration. So I'll show you how to do that in a minute. And then each constant provides a different implementation of the abstract method. Right? So this is a bit odd and probably a little bit advanced for this point in the course. Right? This example comes out of this book down here. There's a link to this book on the course website that you can get to it. You can find it in Queen's Library. All right, so I'm going to make an enumeration that represents the different arithmetic operations of a calculator. Right? So for our purposes, addition, subtraction, division, multiplication. Right? You can, of course, add other operations. Right? So I'm going to define an enumeration for the different operations. Right? So there is a plus, that's the enumeration for addition. Right? Minus is subtraction, multiplication, and division. Right? Now, down here, you see there's a method called apply. Right? So apply takes in x and y. Right? And for plus, you just add the two values. Right? For minus, you just subtract x and y. Times, you multiply x and y. And divide, you divide x and y. Right? So in other words, apply simply applies the operation to the two arguments and returns the value. Right? Now, in this case, that method is marked abstract. So an abstract method is a method that has no implementation. Right? Now remember, if you remember our discussion about interfaces, right? Interfaces are just a bunch of methods that have no implementation. Right? So it's true that interfaces are also just a bunch of abstract methods. Right? So abstract method, no implementation. For an enumeration, if you have an abstract method, every constant must define a version of that method. Right? So now for plus, I have to define how does apply work for plus. Right? And the way you do it is you now use these funny braces. Right? So brace, brace. Right? And now you put the version of apply inside the braces. Right? So plus sort of looks like its own separate little class. Right? And in fact, that almost is what it is. Right? Minus sort of looks like its own little class, and again, that almost exactly is what it is. Right? So plus, right, I define the apply method. Right? How do I add x and y? Well, I just return x plus y. Right? For minus, I have to define apply. Right? How do I subtract x and y? Well, I just return x minus y. Right? And the same for times, and the same for divide. Right? And using this trick, well, not this trick, using an enumeration, you can very quickly implement a calculator for floating point values. Right? You can add your own constants here, so exponentiation, square root, cosine, sine, blah, 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 and so on and so on and so forth. Right? And you can quickly come up with a little application where you can easily implement a little calculator. Okay, so that example there, that's pretty advanced for CISC124. Especially for this point in CISC124, right? I would be happy if you just remembered everything previous to this slide. Right? All right. So when should you use an enumeration, right? So you should use an enumeration whenever you are in a situation where you're creating a class, you want to make objects. The objects are constant, and there's only a finite number of them, right? Wow, these guys are really loud. Sorry, can you guys keep it down a little bit, please? Thank you. All right. Okay, so one of the common cases where you one of the common cases where you really do have two constant values is when you're writing a method or a constructor and it takes in a Boolean value, right? So for example, right, you might make a class called binary digit. Right? Now you all know what a binary digit is, right? So a binary digit is 0 or 1. Right? How do I represent 0 or 1? Well, I can use a Boolean. Right? True is, I guess, 0. No, true is 1 in this case. False is 0. Right? So you might make a constructor for that class, right, that takes in a Boolean value. Right? But now when somebody uses this class, they're going to write new binary digit true or new binary digit false. Right? And then they have to remember that true means 1 and false means 0. Right? Similarly, you might make a class called thermometer or temperature or something like that, right? Where you can specify which temperature scale you're going to use, right? So true for degrees Celsius or false for degrees Fahrenheit, right? But now whoever's using this class has to remember, oh, true means degrees Celsius, false means degrees Fahrenheit, right? If instead you just create a simple enumeration which takes you like 3 lines of code, right? So one is, I'm going to make the enumeration binary value. It's only got 2 constants in it, right? 1 and 0, right? Now when you read that, it's very obvious what this means, right? I've got a binary digit whose value is 1, and I've got a binary digit whose value is 0, right? If I make an enumeration to go along with my thermometer class, right, called temperature scale, right? It only has 2 constants in it, Celsius and Fahrenheit, right? Now when I make a thermometer, I say, oh, well, that's obviously a thermometer that measures in degrees Celsius, right? Or that's obviously a thermometer that measures in degrees Fahrenheit, right? So enumerations can make your code a lot easier to read, right? Especially when you're using Boolean values to indicate one of 2 different things. If you have a set of constants, so enumerations represent a set of constants that you know at compile time, right? That's basically what they are, right? So the card class, do I have this here? So the card class in the notebooks, there's a bunch of different versions of them. One of them uses a string for the rank, sorry, for the suit, and it uses a string for the rank, right? So 2 through ace, right? And a string for the suit, so hearts, diamonds, clubs, and spades, right? But you've only got 4 suits, right? So it makes sense to make an enumeration for the suits, right? And you only have 13 ranks, so it makes sense to make an enumeration for the ranks, right? And if you implement a card using enumerations instead of string, your life becomes a lot easier, right? Because the string, to make a card using strings, it's really awkward. Right? So if I make a new card, and I want, say, the 2 of hearts, right? The problem with this constructor is, does anybody see what the problem with this constructor is? It's a huge pain in the butt to implement, right? Because you have to validate that that 2 is a valid rank, right? So I have to check, is it a 2, is it a 3, is it a 4, so on, all the way through ace, right? And if it's not, I have to throw an exception. Similarly, for the ranks, I have to check, is that a valid rank, right? Is it a heart, is it a diamond, is it this, right? That's a pain in the butt, because you have to now code up this if statement with all of these different cases in it, right? And so that's really awkward. If you use a constant, if you use enumerations, though, right, this is way easier. So now it's just rank 2, right? And now the suit is just hearts. So suit, hearts. And there's no validation here whatsoever, right? Because your ranks, your enumeration for rank only has the valid ranks, and your enumeration for suits only has the valid suits. So there's no validation here whatsoever, and your constructor becomes 2 lines instead of the much longer constructor that you would have to implement if you used strings, right? Furthermore, going from a string to an enumeration is straightforward, right? So you can still provide a constructor that takes in strings, right? You just use the value of method to try to convert that to an appropriate rank, and you just use value of to convert that to an appropriate suit, right? And that's nice and easy. Okay, any questions about enumerations? Super. All right. Next lecture is about, we're going to start to move on to the next part of the course, actually. So this is part 3 of the course. And I just updated this lecture this morning because it had some stuff from last year in it. Nope. Oh, I guess it's already here. Okay. Hello? All right, so we're going to start out. Yes?
What's up with this too? Is it the material for today?
No. I'll post a message about that on Q later this afternoon. Yep. Okay, UML class diagrams. So UML class diagrams, or I guess the language UML, it's a language, but it's a visual modeling language, which is a bit odd, right? So it's basically a language that's defined using pictures, and the purpose of this language is to let you visualize a piece of software, right? So used in software engineering for visualizing the design of a software system, primarily for object-oriented programming languages, right? This diagram that's up here is a UML diagram that describes the UML language. So you have a diagram. You have a UML diagram that describes itself, that describes the language itself, right? So up here, you've got something called a diagram. This represents all UML diagrams, right? You've got behavior diagrams and structure diagrams. So we're interested in these structure diagrams. We're not interested in behavior in this course. You'll learn about that in some other course, right? The structure, there's a bunch of different types of diagrams that describe the structure of a program. We're interested in the class diagram, right? So a class diagram describes what does your class, how is your class designed, right? Okay, so a UML class diagram, well, it's a structure diagram, so it describes the structure of a class, right? And they're very simple to draw. This is basically a box, right? So you have the name of your class, right? And then inside the box, you can put in whatever information you want, as long as it follows certain conventions, right? So for example, you can put the fields of your class in the box, right? Now UML calls these attributes, right? And then you can put your methods in the box, right? UML tends to call these operations. Right? So what does this look like? Well, it looks like this, right? There's our point 2 class as a UML class diagram, right? So the simplest class diagram, it's just the name of the class in a box, right? And that's the only mandatory information, right? Class diagram always has the name of a class, and that's it, right? By convention, you center and capitalize the class name, right? Normally when you create UML class diagrams, you don't draw them by hand. You use a piece of software to do this for you. So the software tends to take care of all the formatting for you. Okay, if you want to, you're allowed to show the fields, some of them, all of them, or none of them, right? It's up to you. It depends on what you're using the diagram for, right? In a compartment below the name, right? So you just draw a line through your box, divide it into 2 boxes. In the next box, there are your fields. The way you read the fields are, the first symbol is the access modifier, right? So minus means private, right? Then it's the name of the field, right? All points have an x and a y coordinate. Then there's a colon, right? Oh wait, the type is wrong here. This should be double and double. Here I've got int and int, but it doesn't matter, right? And then you have the types of your fields, right? So that'd be double and double. For UML, there's a set of 4 access modifiers for the fields, right? So plus for public, minus for private, right? We don't really care about package private and protected yet, but if you want them, there they are. After you show your fields, you can show your methods, right? So they would go into the 3rd compartment, right? And the way you list the methods are, well, it's similar to how you list the fields. There's an access modifier, there's a method name, there's a list of parameters, and then there's a return type, right? You can show constructors as well. So for point 2, I don't know why that's double and double. Sorry, that's a silly mistake, right? So for the point 2 class, there's a no argument constructor that's public, right? So plus for public, right? Name of the constructor, right? Constructor takes no arguments, right? There's a constructor that takes in the x and y coordinate as 2 double values, right? So plus, it's public, name of the constructor, right? Parameter called x, whose type is double. Parameter called y, whose type is double, right? So the syntax that UML uses is different than what Java uses, right? Here you'd write double x, and here you'd write double y. In UML, UML is not tied to any specific object-oriented programming language, so it uses a different notation, right? Let's look at another one. Here we've got a method called x, right? This one, method x, sets the x coordinate, right? So this is set x, the set x method, right? It takes in a parameter whose type is double, and it returns a point2 object, right? So it returns a reference to a point2 object, right? Here's equals, right? So it's public. Equals takes in a big O object, right? And returns a Boolean value, right? It's up to you. So it's depending on the reason that you're drawing this diagram, right? It's up to you whether or not you want to show the fields or the methods. You can choose to show only some of the fields or some of the methods, none of the fields, none of the methods, all the fields, all the methods, right? It really depends on the context in which you're using the diagram for. Right? Here's the assignment 3. That's your ASCII reader from assignment 3. Right? So if you look at the implementation for the ASCII reader, you'd see that it has 5 fields. Right? One of them is a simple image. Right? And there's your constructor. Right? It takes in the directory and the file name of the file to read. Right? There's a method called image that returns the image that's read by the reader. Right? So there's nothing difficult in drawing these diagrams. Right? It's very straightforward to draw one of these things. If your class implements, oh, sorry, I thought I struck all of these range value references, but I guess I didn't. Range values from last year. So if our point2 class, if it implements comparable, so compare points by their distance to the origin, right? You can indicate that on the diagram, right? So you use what's called the lollipop notation, right? So that's the name of the interface, and then you draw a line to the box that implements the interface, right? So this just says point2 implements the comparable interface. Doesn't matter where you draw the lollipop. You can draw it on the left-hand side, you can draw it above, you can draw it below, right? This says ranged value, whatever that is, right, implements the comparable interface. Right? So you can indicate which interfaces are implemented by your classes if you need to on your diagram. Okay, so notice that here you've got an interface and a class, right? So there's a relationship between these two things, right? Point2 implements the comparable interface. Back here, you've got a class, right, called PPM ASCII Reader. Inside of that class, right, it has a field, right? The type of that field is another class, right? So there is a relationship between ASCII Reader and simple image, right? Now the question is what is that relationship? So in general, what are relationships between classes? Right? So you know that by this point you should have realized that an object-oriented program, it's just made up of a bunch of interacting classes. Well, interacting objects, right? But you need a class to make an object. The relationship between classes can be important, right? So classes are built using other classes, right? So the PPM ASCII reader, right, is built using a simple image class, right? So classes are built using other classes, and that implies that there's some sort of structural relationship between classes. Right? Similarly, classes can interact with other classes, right? So in an object-oriented programming, typically you have a bunch of objects that are interacting with one another, right? That interaction is the behavior of the objects, right? So we're only interested in structure, right? Behavior is a whole other can of worms that we're not interested in this course. All right, so what's the weakest relationship that you can have between two classes? Right? So the weakest relationship between two classes is this thing called dependency. Right? So dependency models the uses relationship. Right? So class X uses class Y. So if a class X uses another class X, Y, then we say that X depends on Y. Right? It makes sense. Right? Now it can also be the case that Y also depends on X, right? So dependency can be a two-way relationship, right? You have two classes, X and Y, and they depend on one another, right? So that is a possible relationship between the two classes, right? How can you tell if a class depends on another class, right? Well, if you have access to the implementation, you just look at the source code, right? So X depends on Y, right? If the type Y appears as a field of X, right? That makes sense, right? So you have a class X and it has a field whose type is Y, then yeah, it's going to use class Y, right? If there is a parameter in a constructor or method that takes in a Y object, right? Well then, yeah, you still need Y, right? if your constructor or method creates a y object of some kind or uses a y object of some kind, right, it also depends on y. Right? If one of your methods returns, if one of your method returns an object of type y, then yeah, it also depends on y. Right? So in other words, if y is mentioned anywhere in your class called x, then x depends on y. Okay, so if you want to describe this or if you want to illustrate this relationship using a UML diagram, then you do so using a dashed line and an arrow, right? Dashed line and arrow. So the class that uses the other class, right? You start with no. So the arrow points to the class that is being used, right? So point 2 depends on the class string. Why? Because there's a toString method, right? So there's a toString method, it returns a string, so point 2 depends on string, right? So point 2 depends on string. We haven't really talked about it in the lectures, but if you look at the source code, you'll see that there's another class called vector2, right? Point 2 uses the vector2 class for some of its methods, so point 2 depends on vector2, right? If you look at vector2, there's no method that uses point 2, right? So there's no arrow from vector2 to point 2. Vector2 also has a toString method, so vector2 depends on string. Right? And so that little diagram there tells you something about the structural relationship between point 2, vector2, and string. All right, so dependency is pretty straightforward, right? So if you have a type y that appears anywhere in your class x, x depends on y. Association is a stronger form of dependency, right? So it's still dependency because x is going to use y. Right? But it means more than just uses. Right? So association models the has-a relationship. Right? So x has a y. Right? What does that mean? It means your class x has a field of type y. Right? So if that's the case, then we say that x has an association with y. Right? It is possible for association that y can also have an association with x. Right? So you can have two classes x and y. Class x has a y object in it. Class y has an x object in it. Right? So association can be two-way. Right? Okay, so if you want to draw an UML diagram to show association, then you just draw a solid line between the two classes. Right? So our PPM ASCII reader, right? If you look inside its implementation, there's a simple image object, right? It's a field called there's a field whose type is simple image. So there's simple image, there's PPM ASCII reader, connect them with a line, right? Now, you can indicate how many fields are of type simple image if you want to, right? So the way you read this diagram is that every PPM ASCII reader object, right, has one simple image object, right? So that's what the 1 means besides simple image. Right? So that 1 is called a multiplicity element in the UML jargon. Right? Now, it's important to hear that when you're drawing a UML class, when you're drawing these class diagrams, right, these things here that you're putting in boxes, they have to be classes, right? So they're never primitive types, right? Primitive types you don't include as separate. Primitive types are primitive, therefore they're not classes, therefore they don't show up in class diagrams. Right? You can list them as fields and things like that, but you would never show the relationship of, you would never draw the following. Right? So you would never draw point 2 as the following, right? So point 2 so you would never draw that, right? Every point 2 object has an x and a y coordinate. It's true, but they're double, right? So that's primitive type, right? So you would never draw that, right? If you wanted to indicate that every point 2 object had an x and a y field, you would do that here, right? Minus x minus y, double and double. Right? So we're only interested in the relationship between classes. We're not interested in the relationship between classes and primitive types. Right? Okay, here's a fairly elaborate UML class diagram that uses association. Right. All right, so this is the class diagram that's showing the relationship between a class called show. So that's like a Broadway show or I forget what it's called. It's like a Broadway show, right? So a play on Broadway or somewhere else, right? And the performers in the show. Okay. So this diagram is quite elaborate. So the relationship between show and performer, right? There's this role called orchestra. So this represents the it represents the people in the orchestra for a show, right? There's another role called cast, right? So these are these are the people who are acting in the show, right? Now, how do you read this diagram? So let's look at orchestra. So there's a relationship between a performer, you can be a musician in the orchestra, right? So you have a show, right? Each show, star means 0 or more, right? So each show might have 0 or more members in the orchestra, right? Now, what is the relationship between an orchestra member and a show, right? So an orchestra member might belong to 0 or more shows, right? So here you can see an example of association where show and performer, they have show has an association relationship with performers, and performers also have an association relationship back to shows. Right? The same thing is true of cast, right? So each show might have 0 or more members that are acting, right? Each actor might belong to 0 or more shows, right? A class can have a relationship with itself, right? So here you've got the performer class, right? And notice that there's an association relationship with the class itself, right? So this is an example of the backup role, right? So this is for a performer, right? A lead actor, for example, who might have 1 or more, 0 or more, I guess, people backing them up, which are typically called understudies, right? So each performer, that's a lead actor, right, might have 0 or more understudies, right? Each performer that's an understudy, right, can be the understudy for 0 or 1 leads in this case, right? All right, so that's association, right? So association means has a, right? Dependency means uses, right? Aggregation and composition. So aggregation and composition are stronger forms of association, right? So they still mean has a, but they imply something additional, right? So they both mean has a because they're association, but, so I guess we're going to, what are we doing here? Okay. So for example, if you consider a typical Canadian university, right? Each university has a collection of departments, right? So computing science, geology, philosophy, so on and so forth, right? And each department will have a collection of professors, right? So the difference between composition and aggregation is that composition implies ownership. Right? If the university disappears, right? So if Queen's disappears one day, all of its departments disappear as well, right? So it's the case at most Canadian, I think at all Canadian universities, right? That the departments of a university belong to the university and only the university, right? So in other words, the departments in the university cannot belong to a second university or some other organization, right? So if Queen's were to disappear one day, all of its departments also disappear. So a university is a composition of departments, right? The university owns its departments. Aggregation does not imply exclusive ownership, right? So for example, as a professor, right, I'm appointed in a department, so computing, but I can be appointed at a department in another university, right? So I can hold multiple appointments across universities, or I can even hold another job somewhere else, right? So if a department were to disappear, so if computing science were to disappear, right, then it might be the case that I'm still a professor, it's just I'm not a professor at Queen's anymore, right? So the role of being a professor does not necessarily disappear, right? In other words, the department does not own me, right? So a department would be an aggregation of professors, right? Now, the difference between aggregation, composition, and association is that aggregation and composition are one way. Right? So in association, you can have two classes X and Y, and they can be associated with one another. In aggregation, the relationship only works one way. Right? So in this example here, right, a university is a composition of departments. Right? A department is not a composition of a university. Right? Similarly here, right, a department is an aggregation of professors, right? But a professor is not an aggregation of departments. Right? Okay, so aggregation and association, they're almost identical, right? The only difference is that you can't have a two-way relationship in aggregation. So let's, do I want to do this? I guess we'll stop here because, yeah, I'm not going to get through the whole example before the end of class. So we'll stop there and we'll look at an example of how you implement an aggregation and what it means when you actually do have an aggregation. Right? So just a reminder, there's no lecture on Friday, so I'm going to see you next week for the next lecture.